everybody should be raising their hand because everybody's taking physics, right? Vectors, 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 vectors. So, for example, what would these three vectors represent? What would those three vectors represent? Each of them represents, and flip them around, addition is commutative. So let's talk about this. I left this in here just to show you what I mean. The difference, W minus V is the displacement vector that when added to V gives W. Now here's the thing, I don't really like that explanation. It is technically correct, but the idea is you're adding the opposite of V to W. You're adding the opposite of V to W. You're adding the opposite of V to W. So what do you do to V? You rotate it 180 degrees, and then you add it to W. So this right here is the V vector. Everybody sees the V vector right here? What did I do to the V vector? I rotated it 180 degrees. This vector is W right here. So I took this one, rotated it, and put it right here. So I did W plus the opposite of V. But addition is also what? Addition is, we just said it is commutative. So you could also do, you could do it, what did I do here? Positive V minus W, which ends up being the same thing. Yes, no it doesn't, sorry. No, it doesn't. What am I doing? Minus V, that would be this vector right here. W minus V, like that. When added to V gives you W. The other way you can get that, is you can take this vector right here. The scale is off, I'll make it a little bigger. You take it like, let's say that's negative V right here. Where does that vector also exist? Well, it's right there.
I always liked the comparison that was given when we first introducing vectors, like a pirate map. They're telling
Cross multiply and you get equal signs, right? But there's another way. Scalar multiple. Has anybody heard that before?
Yeah.
I've heard the word scalar.
What does scalar mean? A scalar is just a
real number.
A real number. It's any real number. If two vectors are scalar multiples of one another, what's the only thing you can do to a vector if you multiply it by a scalar? You can only change its magnitude or flip it around the exact opposite direction, right? Or both. But if two vectors are parallel and you multiply either one of them by any scalar, they remain parallel. You can't make two vectors parallel by multiplying by a vector. So therefore, you know that two vectors are parallel. You know that two vectors are parallel if they are scalar multiples of one another. Scalar multiples of one another. So how do you know these are all scalar multiples of one another? Well, that's literally the definition that how they're written out. What do you notice? They're all multiples of what? They're all multiples of V, so that therefore they are all parallel. They're all parallel. Nice. U is the unit vector, and when you see U, it's always going to be unit vector 99% of the time, unless someone makes a mistake. U is the unit vector pointed in which direction? The direction of V. This is the V direction. This is a vector divided by a what? This is a what? What is this quantity?
Magnitude.
It's a magnitude, but specifically what's it called? It's written on the board. No, it's just a scalar. It's just a scalar. This right here is a scalar. This is a number. Scalar. And this right here is a vector. So U in this case is a unit vector pointed in the same direction as V. The scalar right here, magnitude is always going to be what? Magnitude is always going to be negative or positive?
Non-negative.
Non-negative. It's always going to be non-negative, right? Non-negative. So assuming it's not zero, it's always going to be positive. So the scalar can never change the direction in this case. The scalar can never change the direction in this case. Someone asked though, what does it look like? I think Caroline asked me about it. So here's one way to write vectors. In this case, our unit vector, remember, is V over the magnitude of V. So that's going to be I plus 3j over root 10. So if you were to write this out, it would be 1 over root 10 I plus 3 over root 10 j. Another way to write that, which is the much more common way, 1 over root 10 times 1 comma 3. Don't obsess over rationalizing denominators. Don't obsess over making it look pretty. I've been drilling this into my calculus kids as well because they do the calculus and then they spend like 3 times as much time trying to find the best answer. It's totally subjective. That's fine. Stop. Yes?
How did you get
the square root of 1 squared plus 3 squared. That's it. Just magnitude. Just distance. And does anything change if I added it a k? No. It would be the square root of the coefficient squared plus the coefficient squared plus the coefficient squared. Three-dimensional Pythagorean theorem acts just like two-dimensional Pythagorean theorem.
So how come you can't just write like
I'm just saying that these are the same. It's right, you can write these either way, it's fine.
No, I mean, like, how come